For this sample problem, we are going to be focusing on the reinforcing steel for the concrete foundation for Plan 100. So we'll do a couple of calculations that will help us with all of the quantities needed for the different types of reinforcing steel in our foundation, and then we will get into the calculations themselves. We will be looking at the welded wire fabric for the slab as part of the first sample problem, as well as the overlap required based on what is provided in our specifications. We can refer to what is included in Plan 100, but there are a lot of changes that are going to be made. For here, we just need to know that we're having an overlap of 30 bar diameters and that we are using 4x4 W 2.9 by 2.9 welded wire fabric in our slab. We'll then get to the additional information once we get to the second problem set. So starting off, we're just looking at the center line for the front foundation wall. This is what we have calculated many times before. So we have our 36-foot length. We need to subtract out half of each of our sides. So 8-inch side wall on either side. And we get our 35-foot 4-inch center line length. For number 2, it's asking for the center line on the back and sides. So we have our 26-foot 4. Again, we use the dimension which includes the brick ledge because we're moving back to the foundation. We subtract half the width of the front wall, which is 12 inches, and half the width of our 8-inch back wall. And we get 25 feet 6 inches for our sides, but we want back and sides together. We have 2 sides, so we take our 35-foot 4 plus 2 times our 25-foot 6, and we get our 86 feet 4 inches as our final answer for number 2. That's the center line for the back and sides. And lastly, on the center line review, our total center line is either 2 times our length times 2 times our width, or we can simply add the front and the back and sides, and we come up with 121 feet 8 inches. The reason why we're separating them again is because our front wall has a different width than our sides and back, different thickness. We also have different requirements for our reinforcing in those different size of foundation wall and footer. So that's why we need to know what those are separately, but there will be instances where we can look at the foundation system as a whole. So it's a good idea to have all these numbers on hand for doing our calculations. Number 4, then, we're looking for the square feet of our slab. We did calculate this in last week's sample problem looking at concrete, so this again is still part of the review. But remember, our slab runs inside foundation wall to inside foundation wall. So instead of subtracting out half of the thickness of our wall, we want to subtract out the full thickness of our wall. So we have our 36-foot length. We subtract out each of our side wall thickness, and we get 34 feet 8 inches. Same thing for our sides. We subtract out the full thickness of our front wall and the full thickness of our back wall. 24 feet 8 inches. So we just multiply these together to get our full square footage. 855.1 repeating, so roughly 856 square feet is our slab. So then, now that we have our square footage of our slab, we can take the information that was provided us. So we can look and see that we have the 4x4 W2.9 by W2.9 welded wire fabric in the slab. As you recall from the lecture, we can look at a chart. So this is problem number 5. The chart that is in the PowerPoint. These give conversion factors for the different welded wire fabric. So 4x4, that is the spacing of our squares, essentially. So between our longitudinal wires and between our transverse wires, they're 4 inch by 4 inch is our spacing. And then the W2.9 by W2.9, this talks about the type and size of our longitudinal and transverse wires. So W indicates that they are smooth wires, and 2.9 is an indicator of the diameter, the area of the wires that we're using. So we've referred to all of this in the PowerPoint, so this is just review. But this is the information we need to figure out what to pull off of the chart. If we look at the chart and we look at this line specifically, it tells us that the weight is 62 pounds for every 100 square feet of slab. So if we wanted to reduce this down or convert it, it's roughly 0.62 then pounds per square foot. You can use either one, whichever in your calculations. So we apply that then to the 855.1 repeating, which is the square footage of our slab. So multiply it by 0.62 pounds per square feet. Square feet cancels out, and we are left with 530.1689. So roughly 531 pounds of welded wire fabric. Since we're dealing with steel, again, we want to make sure that we purchase in terms of weight. So that's why we convert it to weight. You can convert it to tons if you have a very large quantity. Right now, we can leave it in pounds. That would be sufficient. So the last two problems in this problem set talk about the overlap. So this is talking about when we are splicing two bars together. Since we don't have bars that can go continuously the entire foundation, we are talking about what this dimension needs to be. It's different depending on the size of the wire or rebar you are going to be using. Per our sample problem, we have 30 bar diameters. Number 6, we're looking at the overlap for number 4 bar, and number 7 for number 5 bar. It's actually a very simple calculation for number 4 bar. Remember, we put 4, whatever the number is, over 8. That will give us the diameter, which reduces down to 1/2, 1/2. We multiply that by the bar diameters that are provided. And we simply get 15 inches. This is a diameter that is in inches, so that is why our final answer is in inches. So that means if we're using a number 4 rebar in our foundation, we must splice it together a minimum of 15 inches in order to meet our specifications. And the last one for number 5 rebar, 5/8. It's already reduced. Multiply by the 30 bar diameters. Same regardless. It changes only because the thickness of our rebar changes. And we end up with 18.75 inches of overlap required if we're using our 5/8 or number 5 rebar. So we would need to know these if we want to get down to specifics and understand how much we need to account for waste. If we want to be very precise, we would use bar diameters. Most times, if you're trying to get a rough estimate, or at least initial estimate, you would add a waste factor rather than go into the depth of determining what that overlap would be. But using the center line that we just calculated, we'll be able to then complete our second problem set. So this concludes the first problem set related to the welded wire fabric and the overlap within our foundation.